Good day, viewers. You are welcome back to Tindanious Maths and Science tutorials. I'm very delighted to see you once again. We are still treating calculus. And guess what? I've created a playlist under calculus. So if you want to access a full and detailed tutorials on calculus, visit my playlist. You see calculus, you see functions, that's transformations of functions, as well as complex numbers. Go to playlist and click on calculus, scroll down, then the business begins from there. Today we are going to consider antiderivatives or antiderivatives, which is popularly known as integration. We know that differentiation is the same as what? Derivatives, okay? So the reverse of derivative is what? Antiderivative, which is the same as what? Integration. So in summary, what am I trying to say? Now, the process of finding a function, giving its derivative, is what we call integration. So if I have dy dx equals something, and I want to find for the original function, then the process of you reversing the dy dx is what we call what? Integration. So in summary, the opposite of differentiation is what? Is integration. Okay, so given that y equals, let's say I have x raised to a certain exponent of say n. So let me bring any variable here, c. For integration, when you have y is equal to expression, any expression at all, okay? If you want to find the integral of this, you take integral of what? Of both sides. So when you have an elongated s, this is what we call it, the integral. So we call it the integral of sign this way, okay? So this is what we are supposed to do. We know that for differentiation, let's do a little bit of recap. For differentiation, I pick this. Then what is the next procedure? The next step is you multiply the coefficient of x exponent n, okay, by the exponent. So I have n times c. So what is n times c? N times c is equal to what? It's equal to cn. Then you have what? X to the power what? N. This is the second step. Please, for differentiation. And the last step is, what do we do? For differentiation, you subtract what? 1 from the exponent. So I'll just repeat this over here. I have cn, then x to the power n minus 1 this way. This is all about differentiation. So for this you say what? So you subtract the exponent from what? Or you say you reduce the power or the exponent by what? By 1. That's it. So we start with dy dx. This is dy over then the x this way. Now let's reverse the process. So if I have this, let's say I have cn to the power, that's cn x to the power n minus 1. Then we have this cn s to the power n this way. Then the last one is this cn to the power n. Let's see what's happening over here. Now for this, it was n minus 1. But when we came over here, it was n only. What has happened? It means we added 1 to this expression. So we have n minus 1. So if I add 1 to this, 1 nullifies this, and we have what? We have only n. You get that? So even for integration, what are we supposed to do? We will increase the power. Increase the power by what? By 1. But for differentiation, reduce the power by what? By 1. That explains why this became what? N, because we've added what? 1 to this expression or this exponent. Now, what happened? A cnx, that's cn times x to the power n. All of a sudden, we have cx to the power n. Hey, we ask ourselves, hey, what's happening? Where did the n go? This is what is happening. So if I have cn x to the power n, it became what? Cx to the power n because we divided this by n. When we divide it by n, see the n cancels, and what we have? Cs to the power n. What does it imply? It means for integration, we will divide the whole expression by the new exponent. Here, see the exponent here was what? It was n. You get that? So when you divide this whole expression by n, you get what? The final answer. So here we say divide by the new what? By the new exponent. As a result of that, the reverse process of differentiation is what? Is integration. So we are going to apply this in calculations, and we are going to appreciate that. So this is the whole concept behind it. And we have two types of integration. We have the definite integration, and we have what? Indefinite integration. So in this YouTube session or in these tutorials, we are going to focus on indefinite integration for now. Okay, when we move ahead or more deeper, we are going to learn about integration by parts, integration by substitution, and beyond measure. So that's it. So for integration, the symbol used is what? Is an elongated s, okay, which is what? The integral sign. Then you normally differentiate a function with respect to something. So if I have the x over here, what does it mean? I am doing the integration. That means I'm doing the integration with respect to x. So this indeed tells us what? The function with which we are integrating. So I'll give you more examples to throw more light on this. And the name of this. So for example, if I have integral of 5x then dx. Okay, the name of this is what we call the integrand. So we call this the integrand. Yeah, that's it. And this is what? The integral sign. And this is what, with respect to what we are integrating, with respect to, let's say, x and what have you. Let's consider this. If I have dy over dx equals, when I have a function of, say, y, okay, if I have y which is equal to f of x, when I differentiate or when I find the derivative of y with respect to x, I'll get what? Dy over dx. So I have, when you differentiate y, you get dy dx, which is equal to f prime of x. In other words, when you have y is equal to f of x, when I differentiate this with respect to x, I'll have what? Dy over dx, which is equal to, when you differentiate this, okay, we have f prime of what? Of x. So this is the same as what? It's the same as that. So as a result of that, I can write dy over dx is equal to f prime of x. What do we do now? Let's multiply both sides by what? By dx. So if I multiply here by dx, if I multiply here by dx cancels the s. What do I have? I have dy is equal to f prime of x times what? Times dx. So viewers, this is what? This is the integral, and this is what? We are differentiating with respect to what? With respect to x. Okay, in order to eliminate the d, what we do? We take integral of what? Of both sides. So that this d nullifies what? The integral sign. So what we have? We have 1, which is equal to what? Integral of f prime of what? Of x, the what? The x. So viewers, this is the rule of the game. Alright, so that's all. But what happens? So let's say let f prime of x be equal to anything at all. Let's say a x to the power, let's say n, okay, where n is greater than 0. What happens? So I have y, which is equal to integral of f prime of x, but f prime of x is equal to what? Is equal to this, a x to the power of n. And what we have here? The what? The x this way. Now what is the rule of the game over here? For integration, we always what? We always increase the exponent by what? By 1. So you add 1 to the exponent, then you divide it by what? By the new exponent or by the new power. Simple as that. So I have y is equal to this. What happens? I have a x to the power n. Because we are integrating, we add 1 to the exponent, then divided by the new exponent, which is what? N plus what? Plus 1. Remember, we are doing indefinite integration, and for indefinite integrals, we don't indicate, or we don't have the lower and the upper limits. When you have a situation where you have the upper and the lower limits, we render it what? Definite integration or definite integral. But because we are dealing with indefinite integral, see, when I wrote this, that's integral of this, I didn't indicate any limits. So this is what? Indefinite. And whenever you are dealing with indefinite integral, you always add constant of what? Of integration. This is very, very important. You can be penalized for not adding what? The c. So either c, or in some cases you see k. So where c is what? Is your constant of what? Of integration. Or c is an arbitrary constant. So viewers, this is how it goes, and this is how we differentiate simple functions this way. So what happens if we have, if n, this amount is not greater than 0 but is equal to 0? Let's see what happens. So I'm going to put this into that. So yeah, I would say let f prime of x is equal to, we had this initially, right? But this time around we said n is equal to what? 0. Is that not so? So if that's the case, then I can say that f prime of x is equal to a x to the power what? 0. Because n goes to what? Goes to 0. So I have a, let's n over here, but we have this. Y is equal to integral of the whole of this. So I have y is equal to a x to the power n dx. This way. So I have this way. I want us to be step by step. So I have y is equal to integral of the whole of this, the same as what? The same as this. A x to the power 0 dx. We are not using this because we need to obey the condition, the voice of the question. We say n is equal to 0. So I'm going to take this. So I have this. So I have y is equal to, now what is the rule over here? We said you add what? You always add 1 to the exponent, then divide it by what? By the new exponent, which is what? 0 plus 1. Because this is indefinite integral, you add what? Constant of integration. Viewers, subscribers, please do not forget this. You can be penalized for not bringing constant of integration. So we have y is equal to, I have a x to the power what? 0 plus 1 is what? It's 1. Then all over 0 plus 1 is also what? 1 plus what? Plus c. So therefore, y is equal to ax plus what? Plus c. Viewers, this is the whole concept of integration. In fact, we are going to apply this till the end of integration. Alright, so let's use this concept to solve 1 or 2 questions. Integrate the following with respect to x. With respect to x. So let's go straight to the point. I have this. I have y is equal to x to the power 5. So I have y is equal to the integral, because I'm integrating, you take the integral, okay, of this x to the power 5. And we are integrating this with respect to what? With respect to x. So as a result of that, I'll add what? I'll add the x. Is that not so? So I have y is equal to, for integration, what happens? I have my x to the power what? 5. Then I'll add 1 to it, plus 1. Then divided by the new power, which is what? 5 plus 1. Then plus c. You know why? Because it is what? Indefinite integration. So I have y is equal to x to the power what? 6. All over 6 plus what? Plus c. In other words, y is the same as what? 1 over 6 times what? X to the power 6 plus what? Plus c. As simple as that. Now I have 6x. So this is the same as integral of 6x d what? Dx. Why dx? Dx because we are integrating with respect to what? With respect to x. So I'll have this, that's 6x. Then remember, 6x is the same as 6x to the power 1. Okay, but we add what? We add 1 to the power. Then all over the new exponent, which is what? 1 plus 1 plus what? Plus c. So therefore, I have 6x to the power 1 plus 1 is equal to what? It's equal to 2. Then all over what? The new exponent, which is what? Which is 2. Then plus c. So therefore, 2 divides 6 3 times. So I have 3x squared plus what? Plus c. As simple as that. Then I have y is equal to negative 2 over s cubed. This is the same as negative 2 then s to the power negative 3 according to the law of indices. When you have a fractional index, okay, it becomes this way. So for instance, when you have 1 over a to the power x, okay, this is the same as you have your a to the power x this way, then to the power what? That's negative x. So if I have 2 to the power negative y this way, this is the same as 1 over 2 to the power y. This is, we are just going to apply the concept of indices, okay? So we have it this way. So s to the power 3 comes here. So you are transposing it. So now I have this. So we have y is equal to, then the integral of this, negative 2, then s to the power negative 3 dx. So what is the rule? So you have negative 2, then x to the power negative 3. You add 1 to the power, then divide it by what? By the new power, then plus c. So this is equal to negative 2, then x. What do you have here? Negative 2. Then all over negative 2, the denominator. Then plus c. Clearly, this cancels this. So therefore, I have what? S to the power negative 2 plus c. This is the same as, you see from the question, we are giving this in a fractional form, okay? So I can convert this back to the fraction, okay? So this is the same as what? 1 over x to the power 2 plus what? Plus my constant of integration. Now I have the fourth one to be 4. Now the trick is this. Whenever you integrate a constant, okay, you will have the constant, then the variable attached to it. Okay, so remember that. So this one clearly the answer is 4x, okay, but let me prove why. We are saying when I integrate a constant, I'll get what? The constant plus the variable attached to it. So this is the same as, we know that, so okay, y is equal to 4, which is the same as 4x to the power what? 0. Any non-zero number raised to the power 0 is what? Is 1, okay? So this is the same as that. So therefore, I can say that y is equal to, that's the integral of 4x to the power 0, which is the same as the 4. What happens is this. We have y is equal to, I have 4x to the power, you add 1 to the original exponent. I have 0 already, I'll add what? I'll add 1 to it, right? Then you divide this by the new power, which is what? 0 plus 1. Then plus constant of integration. So I have y is equal to, then 4, then what do we have here? I have x to the power, 0 plus 1 is what? Is 1. Then all over 0 plus 1 is still what? Is still 1. Plus what? Plus c. So therefore, my y is equal to what? 4x. So this is a simple proof. So let us not worry ourselves in doing this all the time. Whenever you have a constant, write the constant and attach to the constant the variable x. As simple as that. Viewers, this is the end of the tutorials regarding introduction to integration. See you next time. Bye.